trade schools teach hard science. For example, heating, ventilation, and air conditioning. HVAC systems are marvels of modern engineering that leverage principles from various branches of science to create comfortable indoor environments. Here's a glimpse into the science behind HVAC. Thermodynamics. At the heart of HVAC systems lies the principles of thermodynamics. Heating and cooling processes rely on the transfer of heat energy between different mediums. For instance, during winter, HVAC systems utilize heat pumps or furnaces to transfer heat from the outside environment to the inside of buildings. In contrast, during summer, they remove heat from indoor air and release it outdoors. Fluid mechanics. HVAC systems rely on fluid mechanics to move air and control its flow within a building. Fans, blowers, and ductwork are engineered to efficiently distribute air throughout the space. Understanding fluid dynamics helps HVAC engineers design systems that minimize air resistance and maximize airflow. Psychrometrics. Psychrometrics is the study of the properties of moist air, crucial for HVAC systems to maintain optimal indoor humidity levels. By controlling humidity, HVAC systems ensure comfort and prevent issues such as mold growth and moisture damage. Thermoelectricity. Some HVAC systems incorporate thermoelectric devices, which utilize the Seebeck effect to convert temperature differences into electrical energy. These devices can supplement traditional heating and cooling methods, improving energy efficiency and reducing environmental impact. Control systems. Modern HVAC systems rely on sophisticated control systems and sensors to regulate temperature, humidity, and air quality. These systems use feedback mechanisms to adjust operation parameters in real time, ensuring optimal comfort while minimizing energy consumption. Material science. HVAC systems utilize a variety of materials engineered for their thermal conductivity, durability, and corrosion resistance. For example, heat exchangers and coils are often made of metals with high thermal conductivity, such as copper or aluminum, to facilitate efficient heat transfer. Energy efficiency. Energy efficiency is a key consideration in HVAC design, with a focus on minimizing energy consumption and environmental impact. Advances in insulation materials, smart controls, and renewable energy integration contribute to the development of more efficient HVAC systems. So is it fair to say that HVAC schools should be considered science and engineering schools? Remember to hit the like button and subscribe!